is integration by recognition. Integration by recognition is a common technique to integrate things that we cannot do otherwise. Let's get an example. There are a few questions here that you can use as your practice this skill. I randomly pick few of them because everything use the same logic. Let's start with this C and D. Differentiate log e 3x square plus 7. So what are we going to do is y is log e 3x square plus 7. 3x square plus 7. The first part of this question is requesting you to differentiate this. Yes, I can differentiate this. Dy over dx is any log 1 over. So it's 1 over 3x square plus 7 and times by the internal derivative. That's the chain rule application, 6x. So now they ask you that the first part, find the derivative of this one, hence we can straight away write by recognition. If you differentiate this, you get this. If you differentiate this, you get this. Means if you go backward, you should get back your original. So antiderivative of 6x over 3x square plus 7 dx is equal to log e 3x square plus 7. The same thing on the reverse direction. Now, not necessarily 6x, any x we can do. For example, using this one, I can find 9x over 3x square plus 7 as well. How do we do that? If 6x dx, this thing is this one, when you divide both sides by 1/6 or divide by 6, this is 1 over 6 log e 3x square plus 7. And then we don't have the 6 here, but then we have to have a 9 here, multiply by 9. So simply you bring this 6 to the other side as a division. This 6 can take out first and then go to the other side as a division. Whatever you need, if it is 9, just multiply by 9 the right hand side. So 9 over 6, so it's 2 over 3 over 2. So that is how you find the integral of something by recognition. Let's get one more. The next one, the one next to it. Differentiate x sin x and hence evaluate this. Now there's a limit here, 0 to 2. If there's a limit here, 0 to 2, yeah, that does not matter. Just put it here and then put it, you substitute the two values and find it. Right, let's get the other one. The other one is using differentiate this one and evaluate this one, x cos x. So if you differentiate y equals x sin x, the derivative is 1 times sin, product rule, this is the product rule, 1 times sin x plus then x times sin x derivative, which is cos x. So sin x derivative is this. Now I can go backward. What did we do? We came forward, differentiate this one, you get this. Now I am asking you to go backward. That's a recognition. Antiderivative of sin x plus x cos x dx should be x sin x. Same thing backward. And then you can split this like this. Sin x dx plus x cos x dx equal x sin x. Because that side you don't need to antiderive. It's just the antiderivative is x sin x. If you don't have limits, put a plus c, otherwise leave it like that. Now in this, we can evaluate this one, sin x antiderivative, which is always the nature is, it may have many parts. Only one part you cannot evaluate, other parts you can. Sin x antiderivative is negative cos x. Plus antiderivative is x cos x dx equals x sin x. Now, if you want, the purpose is to find this one. Then bring all these other side. So it's a x cos x dx on the left, and x sin x is here. Negative cos x become positive cos x. And if it is having a limit 0 to pi on 4, the whole lot should be substituted pi on 4 and 0. We can find it. This is integration by recognition. You recognize the forward side and then reverse the same thing again. I'll get another example. Same, x log e 2x, and then you can find this one. Same. Apply the logic. It's working the same way. I will do question 5 here. Derivative of e to the root x. When you differentiate e to the root x, e to the anything is same, so e to the root x. Chain rule must be applied. That means x square root, you have to multiply this by square root of x. Square root of x's derivative, x to the half x to the negative half. So it's a chain rule, x to the half derivative, half x to the negative half, which means this is e to the root x to root x. X to the negative half is root x. Now, when you differentiate this, you get this. How about if you get back? You should get that. So I write antiderivative is e root x over 2 root x should be equal to e to the root x. Because this one, when you differentiate, you get this. If you anti-differentiate, you should get back this one. Good news is now we can get rid of the 2 if you want, multiply here like this. E to the root x over root x is 2 times e to the root x. Anything, any constant here is not a problem now. Say that you want 5 over 8, multiply both sides by 5 over 8. So you find out antiderivative of 5e root x over 8 root x. What I'm trying to show here is any number here and here, doesn't matter. Just bring that 2 to the other side and then multiply both sides by whatever you want here. So you get the answer. Times by 5 and divided by 8. So simply you can do that. If you don't have a the limits terminals, put it plus c. Otherwise you just don't have to do that. One last one. If you see something like that, using the derivative of this one, using recognition, find antiderivative of, I'll make it a little bit complex, 5x over 3 e to the power x plus 1 dx. The way we use recognition is this: differentiate xcx. So dy over dx is product rule, 1 times e to the power x plus x times e to the power x derivative e to the power x. When you differentiate, you get here. Now, recognition method means you ask him to go get back. Same way, other way. So I can write antiderivative of e to the power x plus xe to the x dx is x ex. When you simplify, or you can split it into two integrals, e to the x dx plus x e to the x dx is x ex. Now what you can do is just integrate this e to the x dx. When you do that, it is e to the x. We don't know this. This is what we are supposed to find. And xex. Now let's simplify this part. Xex dx is xex minus e to the x. What we need is a little bit different. We need xex, but there are two things. We can sort it out this way. What we need is 5 times x over 3. So in here, if I multiply by 5, I can multiply both sides by 5. Divide by 3, both sides. So 5 over 3. 5 over 3, because that is the constant I am having here. Xex, 5 over 3. X e to the x dx is, you multiply by 5 over 3 both sides. 5 over 3. Xex minus e to the x. Just this part multiply by 5 over 3. Now, the requirement here is evaluating 5x3ex plus 1. The meaning is this. What we require is 5 over 3x e x plus 1 dx means 5 over 3x e to the x times e to the 1. E to the x plus 1 means e to the x times e to the 1. You add the powers when you multiply. So what do we need? We need actually this antiderivative of 5e over 3 times x ex dx. This is what we need. This is a constant. So what you do is, if you want that one, take it out, and what we need is 5e over 3 times antiderivative of x ex dx. This is what we find here. Xex antiderivative. So if you want xex, 5e over 3, the answer xex minus ex. This is the answer. If you like, you can expand the bracket. So if you just need this one, 5 over 3 xex dx, it's simply multiplied by 5 over 3. But e to the x plus 1 means you just have an e here. Do it this way. This is integration by recognition. Simple steps. Just try to do few questions from here. And there's nothing super hard other than that.